In number 5, we're working with the rational expression. In our main criteria in a rational expression is make sure we get it factored first. So I want to take the x squared plus 2x minus 15 and factor the numerator, and I also want to take the x squared plus 4x plus 3 and factor that denominator. So in factored form, it's easier to see the zeros, and in factored form, it's easier to see the location of the vertical asymptote. So x and x, plus and minus, factors of 15, that'll give me a 2, plus 5 minus 3. And also on the bottom, it's x and x. Factors have to both be positive, and we want a 3 and a 1. Once I have it in factored form, I can locate the information I need. The domain, the only place that we have to worry about on the domain is never to divide by 0, and the only way that we'll divide by 0 is if x is a negative 3, so we do not want to have, I'm just going to write it this way first, we do not want x to be a negative 3, and we do not want x to be a negative 1. So in the interval notation that we've been using, that goes from a negative infinity up to a negative 3, union that with a negative 3 to a negative 1, union that with 1 to infinity. And that's using our interval notation that we've been trying to be consistent with. The vertical asymptotes, there are 2 vertical asymptotes, and I was asking to please remember to make sure that vertical asymptotes are aligned. And that line is when x is a negative 3, and the other vertical asymptote is when x is a negative 1. So I was looking for them as the equations of lines. The idea behind our horizontal asymptote is a matter of degree, and come back to here and refer us back to it's an x squared divided by an x squared, so it's a second degree divided by a second degree. So when it's a tie, you take your leading coefficients, which are both 1, which means your horizontal asymptote has to approach the ratio of 1 to 1, or in essence that's just 1. So when y equals 1. There is no oblique asymptote. If you have a horizontal, there can't be an oblique. There are no holes because there were no factors the same on the top and bottom. The x-intercepts. The x-intercepts are where your numerator is equal to 0. So now that we have it in factor form, that becomes fairly easy. What are the values I put into the numerator that give us an output of 0? That's what we're looking for x-intercepts. So that's when x is equal to, pick a different color here, x is equal to a negative 5 or a positive 3. So I didn't request anything other than that. What we could have done is a negative 5 comma 0 and 3 comma 0, the actual x-intercepts. And then for your y-intercept, in order to find the y-intercept, you want to plug in zeros for x. I guess in that case, I would recommend coming back in your original equation, plug in zeros for x, and they will be 0, and it's a negative 15 divided by 3. So your y-intercept is going to be at a negative 5. So the ordered pair is going to be 0, negative 5, or just your y-intercept is negative 5.